Thermodynamic assessment of silver-europium binary. Because of their variety technological applications, especially in artificial lighting and their very interested photoluminescence emission, the silver species combined with the europium are widely used in many applications, including photovoltaic cells, photoconductors, and photosensitive for optoelectronics. We present in this study the thermodynamic assessment of silver and europium using CALFAD method. This approach, the thermodynamic properties of every phase are described by means of the Gibbs free energy using all the collected experimental and theoretical available information on phase equilibria and thermochemical properties for the studied system, employing a mathematical model containing adjustable parameters. These parameters are determined by optimizing the fit of the model to many or all the assessed information, also involving coexisting phases. Following this, it's possible to recalculate the phase diagram similarly because the thermodynamic properties of all the phases and the system as a whole. The CALFAD approach represents a powerful tool to describe alloys phase diagrams as a whole using minimum of experimental. In the Gibbs energy function is described by equation of the following forms: for the pure elements, for the stoichiometric compounds and intermediate phases, and also for the solution phases and liquid as this. And for the interaction parameter, we can use the polynomial Ridley-Chester or the Kaptai form, the exponential form of Kaptai. As illustrated in this figure, a comparison between the assessed phase diagram in this work and the data gained from the literature was done. We will show in the following parts of this work that the current assessment replicates the most of the thermodynamic properties and boundary data. We present in the table 2 the optimized composition and temperature of the invariant reactions occurs in silver-europium binary system. We can also show the comparison between the height of mixing liquid in silver-europium concentration measured experimentally by Ivanov and all using isoparabolic calorimetry, and those calculated in this work. We can also show the great accordance with this experiment. On the other hand, no calorimetric measurement of any enthalpy of formation related to the 5 intermetallic compounds appear in the literature. We give in this work and for the first time the calculated values of their enthalpy of formation for the 5 intermetallic compounds. In this figure 4, we present the both calculated activities of silver and europium in silver-europium alloys at 2000 Kelvin. This figure shows that the activity of both elements increases when its fraction is less than 0.5%, which reduces in a notable deviation from the diagonal, which called the Raoult laws.